Our project in the heat transfer course is to compare the numerical solution to the analytical solution of a single rectangular fin. The numerical solution obtained using ANSYS will be illustrated by means of 3 categories. Geometry. The system consists of a rectangular fin enclosed in a box. The first sketch is a rectangle of length 60 mm and a width of 0.5 mm. In order to obtain the fin, this sketch is extruded with a depth of 60 mm and an add material operation. The enclosure is drawn similarly but with dimensions relatively large to enclose the fin with an add frozen operation. The Boolean feature is used to subtract the fin from its enclosure. Mesh. In order to solve the equations in Fluent, the geometry is divided into several infinitesimal elements in the mesh. 6 named selections are done to the enclosure's base without the fin, the fin's base, the inlet, the outlet, the remaining enclosure walls, and the fin's faces. Under mesh details, CDF and Fluent were chosen for physics preference and solver preference respectively. Inflation, as well as face sizing, were inserted for base 1 and the walls of the fin in order to cluster the mesh at the solid boundaries. Skewness obtained. Minimum 1.305 times 10 exponent negative 10. Maximum 0.88. Average 0.22. Orthogonal quality. Minimum 0.06. Maximum 0.99. Average 0.86. The mesh is acceptable. Fluent. Under General, use check and report quality to ensure the absence of any errors. In Models, energy equation should be set to on. After checking analytically that Reynolds number is less than its critical value, laminar was chosen for the viscous option. The materials chosen are aluminum for the solid fin and air for the fluid in the enclosure with the displayed properties. For boundary conditions, base 1 and 2 temperatures are set to 1000 Kelvin, inlet velocity 5 meter per second, and temperature 300 Kelvin. For the wall, coupled is chosen under thermal conditions. For solution methods, under scheme, coupled is selected and second order upwind for the moment and energy options. After setting the previous conditions and choosing the desired number of iterations, the solution is successfully calculated. A contour of static temperature of the wall is displayed to show the temperature gradient along the fin. In addition, an XY plot of temperature on the center line of the fin shows successful solution. Using reports option, 78.6744 watts is obtained for the numerical heat transfer rate. Team members: George, Abi Younes George, Ghoussoub Marie, Lutfallah